Okay, guys, so now we come to the longer part of what you have to do. You were asked to find the areas of all the squares and look for a pattern. So now we're going to look down, check your answers, and you can record your answers on the squares that you have in front of you. And let's see how you did, and we're going to talk about the pattern as well as look at a couple examples. So I'm going to move you now. Move you down here. All right, so let me move you up. So the first one was number 1, and I have the area is 1, 4, and 5. So number 1, I got 1, 4, and 5. Turn it like that. And then on number 2, I have area 1, area 1, area 2. So I have, let me move this up. So I have 4, 1, and 5, 1, 1, and 2. And then down here I have this baby square has area 1, and this one has 3, 6, 9, and this one is 10. And then over here, a bit closer, I have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this was 13, and I added that up by cutting it up into the little pieces. Okay, so now I want you to look and consider the big picture. We have, turn this here, we have 4, 1, 5, 1, 1, 2, 9, 1, 10, 9, 4, 13. What is the pattern? Well, the pattern is that these two smaller squares add up to the hypotenuse square. So these two smaller or leg squares, 1 and 1 is 2, 9 and 4 is 13, 4 and 1 is 5, 9 and 1 is 10. So let's turn the piece of paper over and let's look at the next one, number 5. So if you look at number 5, I know this one is 4 because there's 4. And I noticed that these two squares each are the same size. So they have to be 2 and 2 to add up to 4. So this has to be 2, this has to be 2, so this can be 4. Okay, now, so that one was a little more difficult. Number 6 is even more difficult. Because what do we have going on with number 6? Well, in number 6, we have leg that is 3. So if this side is 3, what will this side be? Well, this is a square, so it's 3 as well. And it's a 3 by 3. So the area is going to be 3 times 3. So the area is going to be 9. Okay. This hypotenuse length is 5. So that means this side has to be 5 because it's a square. So this area has to be 5 times 5. So this area has to be 25. So if that area is 25 and this baby small area is 9, what is this missing area? Well, we know that this area plus this area has to equal 25. So this missing area has to be 25 minus 9. So this missing area has to be 16. So if this area is 16, what size is this square? Well, let's think about that. So the area has to be 16. So it's this side, we'll call it L for leg, and L for leg. So leg times leg equals 16. That means leg squared equals 16. So the leg has to be the square root of 16. So this leg has to be 4. Did I have to do all that work? No, I could have just noticed that it's 4 times 4 is 16. Okay. But that is also one way to do it. Okay, so now we're coming to the part of in your own words, describe any relationship you see between the areas of the three squares. So what is the relationship we see? Well, one, we know we have a right triangle and it has two legs. It has a leg here and a leg here, and it has a hypotenuse. The hypotenuse is the largest side, so that means this is going to be the largest square, because if you have a longer side, then you use another longer side to make the square. So one way of saying it is that if I take these two squares and I cut them up, they will fit perfectly into this. How can we say that? So let's try. Let's see. So hopefully you have put something down on this. One thing I said is that the area 1, this area down here is number 1, this area, however many squares that is, plus area 2, which is this one over here, equals the hypotenuse area. So area 1 plus area 2 equals the hypotenuse area. So if this is 9 and 4, this is 13. If this is 5 and 6, this is 11. If this is 4 and 4, this is 8. If you know this one and you know this one, then you would figure out this one, or vice versa. Another way that is, we could say the areas of the two smaller squares equal the area, or equals the area of the large square. Okay, now the two smaller squares are called the leg squares, so let's put that in parentheses, and the large square we call the hypotenuse square. So let's put that. So that's another way of saying it. So here's one way and two ways. The next way we could say is, how is this square made? Well, this is an A and an A. So these are squares. So we could say leg squared plus the other leg squared equals the hypotenuse square. So the two the baby squares equal the big square, which is kind of what we said here, and also kind of what we said here. Let me fix this one. This one we said the two baby squares equals the hypotenuse square. Okay, one other thing. One last thing. So this is 3 ways. Let's add one fourth way. This way you're probably more familiar with. If this square is A by A, then this area is A times A, which is A squared. And this square is B by B. So this area is B times B, which is equal to B squared. And this square, we called it C. So this is C by C. So the hypotenuse area is C times C, which is C squared. So the other thing we know is that A squared plus B squared equals C squared. Have you, I don't know, ever heard of that before? A squared plus B squared equals C squared? Well, turns out you have. It's called the Pythagorean Theorem, and I tricked you into doing it. Maybe some of you figured it out before this point, but over here, this is an example. All of these pictures are examples of Pythagorean Theorem. So in other words, if I take these 4 squares, I could fit them right here. 1, 2, 3, 4. And then if I take these 9, I could fit them in around the 4 and fill it in. And that's what the Pythagorean Theorem says. The area of the two smaller squares equals this area of the hypotenuse square. And that will always work every single time. So now we're going to look at an in-class activity that we normally do and how it works, and look at a couple of examples. So there you go, Pythagorean Theorem. but this is a visual picture of Pythagorean theorem.